Me, Miguel, we're both in call with Iyad as well. Iyad is also in call, working on
At
the
4 a.m.?
controller. Yeah, 4 a.m. Everybody, we it was us. So us three were in call, and Max wasn't in call, but he was working as well. It's four people working at 4 a.m. yesterday. Well, this morning. But it's good because this stuff that like this the issues that we worked on right now is like basically like the base for everything else that people are gonna do. So it's good that we're getting this done early. Okay, so all right, so essentially what we're gonna do is I'm gonna run you guys through how to make scenes and how to essentially make a Godot game, Pong in this case. I'm gonna try my best to use as many like kind of ideas that we're gonna use in the project. Um, but there's some things that are just overkill, so I'm not gonna use. So to get started, there's a couple things that we need to set up. I just made like a simple like uh, fold tree here with assets, which is just this is gonna be our ball, global folder, a scenes folder, and a scripts folder. The project is more detailed on how the folders are, but it's just for organizing yourself. First thing we have to do is in the project settings. We need to go into project settings, and there's two very important settings here that we're gonna use a lot. So one of them is input maps. Godot by default has a lot of input maps. Um, Usually they're denoted by UI underscore, and for example, like if you press the arrow keys, it will send an input. But we don't actually want to use these because they're meant for kind of like fallbacks, and they're not necessarily meant to be changed, and they're not very clear. Like UI left could mean a lot of things. So in general, we want to make our own input map. So some of the simple things, you could have like up, down, left, right for movement. In this case, we only need two because we're doing Pong, and later you're gonna see that all we're gonna do is make sure that our paddle can go up and down, right? So we're gonna have two input maps up and down, and we're going to assign a key to them. So in this case, it'd be W, and we're gonna do S.
Where's the map thing? I
That's
just like
in
created the.
Yeah, it's okay. That's in project, and then
Okay.
yeah, once you click project, you project settings, and then input map.
Okay, same.
Okay, so yeah, this is the input map. Basically, you just name an action that you're gonna use in your code. You add it, and then you assign a key to it. This also work with controllers. So if I connected my controller right now, and I pressed up, and I like moved my joystick up, you would actually recognize the joystick going up. So it's extremely simple to add inputs, whether in your controller or on keyboard and mouse. Um, just need to make sure they're consistent. Okay. And then there's another one that's called global. Global essentially allows us to put a path to a scene or node or script here. And what it allows us to do is essentially have that directly on the root of our project. So our entire program, no matter what nodes, what scripts, what scenes we use, they can all have a reference to the global variable. So just think like a variable that you can access throughout your entire code base without having to explicitly have like a exact path for it. There's only one global variable we're actually gonna need here, although we can't make it yet because we don't need to have a script for it. So there's one thing that I'm gonna make. It's a script called event bus. If you guys seen in the project, um, one of the only scripts that's there right now actually in the dev when you pull is the event bus. This is gonna be one of the most important scripts in the whole code base of our game because we're gonna use it to essentially route all of our events and our inputs through there. So I'll show you guys in a little bit. So you're gonna
How do
make
you,
yeah.
how do I like I just created the thing. I don't have like the global folder, like the scenes folder, the scripts folder, or anything like that.
You can make
Create
them,
that.
or you don't like. I only made these folders to make it a bit easier, like organizing
Oh,
it,
you
but you
just
don't need it.
created new
Yeah.
folders.
Yeah, you
Oh,
just make new folders. Okay. Let me know when you're good.
yeah, hold on. I'm I thought it was good, but they keep like every time I make a new folder, it goes under my resources folder.
Um, did you make a resources folder?
I just like double clicked the box and I clicked new folder.
Oh wait, are you talking about the res?
Yeah.
Yeah, so the res, that's your root. Every folder in the project is gonna go under res, so that's okay.
Oh, okay.
Um,
Okay.
all right, I'm gonna keep going. So, um, we're making here a C# script. Make sure that on default, you guys are gonna show up GD script every time because you're using Godot, so it thinks you're gonna use GD script. But we're different, so we're gonna use C#, and you're gonna select C# there. Make sure it's a CS file, and then you can just change this name here to whatever you want. Um, in our project, we have an event bus script just like this, and here we're gonna have one as well. You'll see in a little bit why. So in our event script, we can open this already. Actually, drag this here. Oh, it's not okay. Boom. Okay, so in our event bus script, it's empty right now. This is like the default look. It has a class with the name of the script and the type of node. This is what it inherits from. So essentially, this event class has all of the properties from Node, kind of like a Java file when you do like car extends vehicle. That's basically the same thing. Event bus extends Node. This is what this is saying. Um, and yeah, this is just a default Godot. You have to use this so you can use all of the Godot properties. This just comes with a file. We might not use it. I mean, probably won't. So you can delete this or keep it. It's up to you. It doesn't really matter. Um, okay. So what we're gonna do, we're gonna go back to where we were before in the global, and we're gonna make this script a global script, so we can access from anywhere in the project before start. So all you have to do is you click on this folder icon, and then you find where what script you want to put it. You want to put the event bus, and then we can just keep it the same name. That's fine. And then we can give it a node name. I usually just leave the name of the script itself as this name, just to make it things simple. And then that's it. Now, this script is global, which means it can be accessed throughout our whole project. So now, before we actually start
Do I need to do
making,
anything after filling out the path or no?
yeah, wait, what?
Like, what is the node name supposed to be? Is it supposed to be an event bus?
You can. I usually tend to just put event bus, which is the name of the class that we made, but you can name it whatever you want technically. You just gotta make sure that's the name that you're gonna be using when you're referencing it. So
Okay.
it's easier to just leave it the same name as your script, so then you know. Okay. So before we actually start doing things here, and I like running through everything, how everything works, we're actually gonna write some things on this event bus. So the main reason for an event bus is so we can have things called signals, or in C sharp more known as like events, in our game. What that what that is essentially when you press a button, right, or anything happens. For example, easiest example is when you press a button, he gives off a signal, and then a computer or a keyboard registers that, and then does something with the signal, right? So this is exactly what the same thing. So we're gonna say signal in brackets, right? And then under that, we're gonna make a couple of events here that we want that we're going to use throughout the game. So we're gonna have this is how you say about it. You do signal, and then public delegate void, and then you do the name of your signal. So um, there's a couple signals we need. So we need to know when the player scores, right? Whenever the player scores, we need to launch a signal or ping it. We need a AI scored because whenever the AI scores on us, which will happen a lot, we need one, and we need um, a signal to speed up the ball every. The way I'm gonna do it is I'm gonna have it speed up every about 5 seconds. So we need a signal to know when we need to speed up the ball, and we need a signal to when the game ends. Okay, whenever we get scored on, we need to know when to restart the game, right? So the first one we're gonna make is to make it player scored event handler. So in C sharp, it's very important. C sharp slash Godot, right? It's very important that whenever you name a signal, You have the name of the signal, right? Which in our case is player scored, followed by event handler. Okay. By the way, this is not Pascal case, which means it's capital, 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 capital. Okay. So, um, name of signal, event handler. Event handler is always gonna be at the end of your signal slash event because Godot uses event handler to when the C sharp compiles, uses it to figure out what's a signal and what's not a signal. So if I just had this as just player scored, see, it won't work because the compiler
Mm.
doesn't know what it is. But if whenever you put event handler, he understands that okay, this is an event, so I should treat it as an event. Um, I'm gonna leave it at that because you know we're not learning about Godot engine here. We're learning about how to make games. So you don't really need to know this. You just need to know that it's very important that whenever you want to make an event, you need an event handler at the end. And whenever we do use the actual signals themselves, this is like even easier to understand because you don't actually call like player scored event handler. You only call it player scored because the name of your signal is player scored, not player scored event handler. So just keep that in mind. And then let's make the other ones. We also said we needed a signal for when the AI scored, right? So signal public delegate void AI scored event handler. I mistyped something. I'm fixing a bit. Delegate. Okay. Oh, delegate. Okay, so we got a AI scored to event, and then we also need one for we said when we want to speed up the ball, right? So then let's go again. Delegate void void speed ball event handler. Okay, and then we need one more signal, which we wanted to know when the game restarts, right? So public delegate void restart game event handler. Okay, so now this is essentially our entire event bus class. Okay. In our main project, in Project Rory, we also have an event bus script, as you guys saw, and this is essentially what you guys will be using that script for. Is whenever you have a script, like whatever you're working on, whatever scene script you're working on, if you know that you're gonna need signals, you need something, or you can just make a signal here and connect it. Or better yet, because everybody's gonna be using this, if you're interacting with someone else's scene that they might have made, right, and you need to use their signals, the signal's already gonna be here. So I'll show you how you can easily just subscribe to the signal, and this is gonna make work very easy for everybody in the long run as like the project grows, since there's gonna be a lot of signals that we're gonna have access to. So here, I'm not gonna actually put a comment on what they are. Um, in the project, I recommend that if you guys can't make the names descriptive enough to know, that you guys put something or like this signal does X or something, or like so people know what it is. If you don't want to do this, just make the name descriptive, please. And that's essentially it for our event bus script. So now we're gonna start making the game before actually keep going here. So what I like to do is I like to make everything that I need first, and then I like to make the scripts after that. So I'm gonna make this a bit bigger, and we're gonna have a couple of scenes here. So the first scene we're gonna have, we can just call this game, right? This is where our game is gonna run, and we can actually just choose this one as our main scene that we're gonna run. So scene we can name. Go. It's gonna build, just make sure. Okay. So we have our game scene. Inside of our game scene, there are a couple of things that we need, right? I'm gonna turn on the grid so it's a bit easier to put
What
things.
did you do to the game scene thing? What was that one thing you did to set it to like the primary thing?
Um, oh, you just press play and it's gonna ask you to choose a primary because you haven't chosen one. So
Oh, okay.
you should see it pop up when you press play. And then it should like once it does run, it should just be gray because we have nothing in our scene. I'll also show you guys how to export the game if you guys want to just download it on your computer afterwards, so you can play it. But that's later. Okay, so inside our game scene, we're not gonna put in scripts yet. There's a couple things we need, right? So first, we're gonna need a top and bottom, right, to where our ball is going to collide. Well, actually, before I actually do that, so let's look at Godot a bit. So the 3D we don't care about. The 2D scene or like space, this is where you see your scene and where you visualize nodes and whatever is like in your scene. The script is where you code, except that we're using VS Code. So whenever we open script, it's not going to open this, it's going to open VS Code. And the game is also where you view the game, where if you press here, it will actually populate that. But if you press on your debug on your VS Code, it's going to make an external window that also does the same thing. So um, you don't really need to worry about all these, just the 2D. The plus sign over here allows us to add a child node, and these are all of the nodes in the game, right? As you guys can tell, there is one main node which is called node. This is the default node of all nodes. It's like the parent of everything, right? And then it's a very big tree structure. We're not going to be using 3D nodes, so you don't need to worry about that. Um, and then within canvas items, there's two types of nodes: 2D nodes and control nodes. Control nodes, if you guys, we're gonna use it later. These are for UI components. So for HUDs, UIs, UX, like all that stuff, buttons, um, inventories, all that stuff, you would use control nodes. They have special features that allow them to be like to work in a bit different way than other nodes, since these have to always be detecting things because they're UI. You know, whenever a person like sees a button, like they gotta be able to press it, and you have to be above the entire game. So they have a bunch of different like they have some different functionalities. You guys will figure it out as you're using them. And then here, the blue one, we have our normal nodes. This is basically what you have for sprites. You have for audio streamers. You have particles. You have your camera. You have your collision shapes. Markers. There's a bunch of things here. You guys, look around. You figure out how this stuff works. Time at players when you're making maps, and even like touch screen buttons, because you can also make phone games. By the way, on Godot. And then you have the animation mixer where you have your animation player, animation tree. That's kind of it. Uh, yeah. And then there's some other extra nodes here for AI, multiplayer connectivity, API connectivity, all that stuff. So everything's through nodes. Well, the nodes we're going to be using right now, though, to make the top and the bottom, is we're going to be using something called a rigid body. Not rigid body. Static body. So static bodies, essentially, they can be moved. They're like walls, for example, right? So that's why we're going to be using it. And we get this little triangle, yellow triangle. It's telling us the node has no shape. So whenever you have a node, any node in Godot, if you guys noticed on the right side of my screen, it pops up something called a inspector, right? In this inspector, there's extra functionality that each of these nodes have. So, for example, the basic node 2D has material, texture, ordering, visibility, scale, rotation, and all these things. And because static body 2D, as we saw earlier, is an extension of node 2D, it also has all of those things plus its own specific like functionality. So you see how it has their own static body 2D things here, but it also has the transform visibility from node 2D, as it's like shows here. You see node 2D, static body 2D. So because this is an extension of node 2D, it has all of the features. So we're gonna be using this to make our walls. So we can just name this top, right? And then we need to add it's telling us to add a shape, correct? Yes. So then we'll here, and we get a collision shape. Collision shape is what you add to a node or anything that you want to collide with. You add it, and then you look at the inspector once again, and you choose a shape. In our case, we're just gonna use a rectangle, and we can actually make this rectangle really big because it's gonna be the entire top of our game. So I'm using the grid, so it's a bit easier to like see it. Here we go. Then we can put that. Oh, by the way, these lines over here, this right here is the center where all of your scenes start. Your game screen, whenever you run this, This screen is depicted by the pink line and the blue lines and this green line. So this square here is that scene. Anything that's inside of this, you can see it when you run the program. So that's why we're making the top here the size of the top, so we can. Um,
Where'd you gonna make that rectangle?
you click on inside your collision shape. You click shape, and then you can just
Oh, okay.
change it, and make it look how you want. This is making look fine, I guess. Okay, so now we have our top and our collision shape. Now we can just duplicate this, honestly, and call it bottom. So, and then with the bottom one, we can just drag it to the bottom. Okay. And then now we have a top and bottom of our game. So whenever a ball gets here, it's going to bounce off. And yeah, so we built that, and then now we need to build the area where actually no, let's build the paddles. Well actually, okay, so look, this is what we're gonna do. For the rest of the game, we're going to make a scene for each of the individual things. So for now, this is our game scene. So what we're gonna do now is we're gonna make our paddle scene. So that's what we're gonna use to hit the ball with and like move it up and down and whatnot.
Hold on.
So
Can you
yeah,
like 1 second just to duplicate the top and bottom?
it's okay. So let me know when you're ready.
Yeah, hold on.
Called Chris,
Yeah.
do we make sure to also duplicate the left and right or no?
No, we're not making the left and right yet because the left and right is not gonna be a wall. It's gonna be where we detect
Okay.
whether the ball has been in or not. So
Movement.
yeah,
Yeah.
so we'll get there. So for now, just you should have the game node and the top and bottom walls here. Um, yeah,
I'm almost done. Just give me a
it's
second.
okay. It's your turn.
Okay, I'm all good.
Okay. Chris, you good?
Yeah, I'm chilling.
All right. So we're gonna click here the plus button at the top. This is where you see all of your scenes. You're gonna press new, and then we're actually gonna make a new node, but we're not gonna make it off a 2D scene because what we want to make is we're making the paddles, right? So because we're not actually making a whole entire scene, we want just a specific thing. So for example, what we're gonna be using for the paddles are also static bodies. Um, so we're just gonna make the root node a static body 2D, okay? And then inside of it again, we need our collision shape, right? Boom, collision shape, and we're gonna make that a rectangle as well. The biggest difference here, though, is that we're also gonna have one more thing. We're gonna have a color rect. So we're gonna have this is a color rectangle. It's mainly used for UI, but because of what we're doing, we can use it for like just to showcase like because we don't have texture or anything, so we can just use it for this. It's okay. Um, so we're gonna make color rect 2D, and not 2D, just a color rect. And then what we're gonna do is we're gonna shape this into a rectangle. More like a paddle. So I think what is this good? Yeah, I think this is about. Yeah, this is good. Make this, and then with the collision shape, we chose a rectangle. Remember, so just let's align. Let's align. What the fuck? Oh, let's make that a bit correct so it doesn't like. Okay, boom. There, and then let's just make sure it covers. Make sure the collision shape covers the entire color rect that you make, and then we save the scene. We're gonna call it I don't know, paddle. It's fine. Paddle. Okay. Okay, so now we have our paddle scene. All right. So with this paddle scene, we can go back into our game and let's put some pedals in our game so people can actually play it. So we're gonna put one here. All right. This is where the player is gonna be. Let's make
Is
sure
the
it's
is the hitbox or the collision box supposed to be over the color rect? Because mine's like behind it.
So it doesn't actually matter whether it's over or not when it comes to collision boxes like this. It doesn't really matter, but the way it works for future reference, the way that nodes get drawn in the tree is from bottom to top. So whatever is in the bottom gets drawn first. So if I put my color rect in front in the bottom, you see the collision shape is behind it now. But if I put the collision shape on the bottom, then now collision shape's on top. So whatever's at the bottom gets drawn. Well, actually gets drawn last. Sorry, it's from top to bottom, but like whatever like is in front is the bottom-most. So yeah, it does. This
Um,
doesn't really matter because it's gonna detect shape anyways, as long as it's the same shape. Let's make sure the shape's the same. Um, this does, however, matter a lot when you're working with UI and making sure it's in the right layers, or you're working with sprites and you're making sure like certain sprites are in the right layers, so on. But that's not. That's kind of outside of scope of Pong. So yeah. But okay, so in our game, we're gonna put our paddles up here. So we're gonna have one paddle on the left side. It doesn't have to be perfect. Just like like uh, like try to put it somewhat in the like middle. Doesn't have to be perfect. And then we're gonna actually duplicate this twice, and we're gonna move the other one to the opposite side. So like here should be good. Here should be good. So now we have two paddles, one left and
how
right.
did you
Yeah.
how did you import the paddles?
You can just drag them from the scene into the thing.
Well, like, cause like my I'm still like I don't know how to explain. Like they're not like they're still on the other file. Like they're still in the other.
Yeah, they're here,
They're not.
right? In
Yeah.
their own thing. So go to game, and then over in the bottom where you have your scenes, you see it?
Yeah.
You just like hover over it, drag it, and then drag it in.
How do you wait? What? I did not add
You
that to the
like
scene.
oh, where did you save it?
No, I guess I didn't save it. How do I save it?
Control S. Then it's gonna ask you to save it somewhere, and then just save it in your scenes.
Not doing anything. Oh, is it command? Oh, okay, I see.
Like Command S, sorry.
Yeah, yeah, yeah.
Did it
Okay,
save?
I got it.
Okay.
Yeah.
So then in your scenes, you just make sure you go in and you drag it in, and then you can just duplicate it with. In Mac, it's Command D. In Windows, it's Control D. You just do Control D and then drag it the other one to the other side.
And this is supposed to be under game or supposed to be under
We're
bot?
we're we're making the entire game scene right now. So under the game,
Okay,
in the game scene.
okay, okay. Got it. Thank you.
All right, Chris, are you good?
Yeah, I'm sure.
Okay, all right. So now we have both of our things. Let's make sure know we can like differentiate them. We can name this one player, right? And then we can name this one enemy, right? So then we have our player paddle on the left, and then we have our enemy paddle on the right. So now let's make a scene for our ball. So our ball is actually not gonna be a static body; it's gonna be a character body 2D. This is so we can apply physics to it, and we can bounce it off walls, and we can apply velocity and do all those things. So we're gonna make a character body 2D, and we're just gonna name this character body 2D ball. Okay, and then it's screaming at us. Godot loves screaming at us that we don't have a shape. So let's make sure we add a shape. Um, Collision shape, and we're gonna use our icon here, right? I said we were gonna use our icon for our ball. So actually, let's just give it a shape here. I'm gonna give it a circle shape, even though the icon's square, but you get the idea. And we're gonna also have a sprite 2D. This sprite 2D is what we're gonna use to put our icon at. So you see here in sprite 2D it says texture. You're gonna get your icon. This icon, by the way, is default with Godot. It's always gonna be on your root. You can just drag it, and there you go. We have the Godot logo as our ball. And then just make sure you do Command S, Control S to save it. Save the scene, whatever name you
How do
want.
I drag the texture in? Oh, is it? Oh, I see it. Never mind. My bad. I see
Okay,
it.
no, you're good. So I'm gonna actually put the collision shape under a sprite so we can kind of see it a bit more. And we're gonna make this sprite a bit smaller because I think it's way too big. So over here under transform, we can change the scale. I'm gonna make the scale 0.25. so quarter of the size. And then we're also gonna go into collision shape, and we're gonna make it a bit bigger. You're gonna see that orange dot. You just drag it, make it about the size of that. It's okay. And then that's our ball. I mean, that's it, right? Like, this is all we really need for our ball. So we can save that, and then we can go to our game, and we can just drag our ball into our game scene. So you might be asking, oh, why are you not putting the game scene in the middle? We can put it here, it's fine. But you're gonna see later, the way we're gonna do it is, so it always starts in the middle of the screen. We're gonna move the position through code, okay? So it's okay just to leave it outside of the scene for now. So we can leave it outside of the scene, and then now we're going to make let's see, what should we make? Let's make the goals, okay? We're gonna make the left and the right side of the screen. So the way we do that is also, again, we make another scene. I hope you guys are starting to see some patterns here with making games in Godot. We're gonna make a new node. This time we're gonna be using an area 2D. So the reason for that is because, as it says here, a region of 2D space that detects other collision object 2Ds entering or exiting. A collision object 2D is essentially any object that has a collision shape. Any object, if it has a collision shape, it's a collision object 2D. So essentially, whatever goes inside of this area when it has a collision shape, it's going to be able to detect it. So that's what we need for when the ball goes to the left or the right. We know that either the player or the AI scored. So we can just make that as a root, and then we can just call this one player go. Yeah, I mean, that's okay. Player go, right? And then inside of it, again, it's yelling at us because we don't have a collision shape. Let's add a collision shape. Here we go. And we're going to make it a rectangle once again. This time it's for the left side, so let's make sure it's like aligned a bit to the left here. There we go. Oh, wait. Okay. Make sure it's like there, so, you know, it's not like overflow or anything.
The left like
Let's-
boundary.
Huh?
Like the left like boundary of the screen.
Wait, what? Sorry?
Like where do you align it with? Is it like the left boundary of the screen?
Yeah. I'm lining up with the left boundary of the screen.
Okay.
Remember, whatever is inside of the square is your screen, and whatever is outside is out of it. So whenever the ball, what we want to happen is when the ball gets out of the screen, aka enters this outside area, it detects. So to do that, we use this player go, right? And then we're gonna do the same thing. So this is basically it for the player go. We can just save that. And then we're going to actually duplicate this scene. So we're gonna do Control D. Over here in your files on the left side, you go to your player go. You can do Control D or Command D, whichever you're on, and then you're gonna duplicate it, but we're gonna call it AI go, right? Because that's the name, AI go. That's the name of the other side.
Want me to duplicate it one more time? Sorry.
You do
Can you
Control
share
D or Command D. You just click on it and
like oh okay, see Control D. Or
or
Command D, okay.
Command D, yeah. So okay, so we make our AI go. If we open our AI go scene, it's gonna have the same name. Let's change this to AI go. So then our AI go scene and our player scene. So I got AI go and our player go. So they're both on the left, but that doesn't matter. You see why. So now in our game, let's put in our goes. Right? Let's put our AI go first. See. So as you see here, even though it's on the left on this scene, it doesn't matter because what's being moved is this pivot point. Whenever you drag scenes in, what's being moved is the pivot point, not the actual like the screen itself doesn't come with it. It's just the like objects of it, and then you move those through the pivot point. So we're gonna put the AI go on the right side here, right? Because we're gonna be controlling the left data. Make sure it's aligned there. It should be because we aligned it before, and then save it. And then we're gonna put our player go over here on the right. So boom, boom. So now we essentially have our setup here, right? We got our ball, we got our pedals, we got our whole thing.
Wait,
There's
hold on.
yeah,
I'm sorry. AI
you're good.
goes on the right or on the left?
On the right
Okay.
here, what we can do is this. I'm going to give it a different color So over here on collision shape, you can actually change the color. You can change the debug color. That means it changes like the different color collision. And then for the AI, we're gonna make it I don't know, yellow. So here you can see uh, the AI goes yellow, the player goes pink, and then the blues is our walls, right? Okay, so now we have this setup. There's one thing we're missing though.
You have to click control.
What?
You have to click Command S again when you. Okay, yeah, okay, never mind.
Command
My
S to
bad.
save, yeah. You guys. So now we're missing one thing. Do you guys know what that thing could be that we're missing?
Code.
The code.
Well, not yet. We're still not in the code. We're still not done building the game. There's one more thing we need to like build the game though. Like,
Walls.
huh?
Like a little wall, like a background.
I mean, we could, but we're not gonna do that. That's just like aesthetic. Like, but the main thing we're missing is a way to tell the score, right? Like, we need a scoreboard. Otherwise, like, we don't know who's winning, and we don't know like how much time it's been. Like, we don't know anything. So we're gonna make a simple, very simple AI here, not AI, UI, so we can see our scoreboard. So we're gonna make a new scene, okay? But this time we're actually gonna use a different node. We're gonna use a UI node. This is essentially what holds any like UI layer stuff. So as you can see, it's like instantly makes a huge box throughout the entire visible screen. Because it uses that to like say where it's at. Let's just save this real quick already. It's fine. So inside our UI node, there's a couple things we want. So first of all, um, we're going to have a panel container. So a panel container is essentially keeps its child node controls within the area of a style box. So it's basically so we have everything like looking nice, I guess. And what we're gonna do is we're going to actually anchor it to the top. Actually, yeah, we're gonna switch to the top here, and then inside of it, we're going to it's like we're anchoring to the top middle. You see, over here. Sorry. Whenever you have UI nodes, this little extra section pops up. These are anchors. It basically tells where in the screen it's gonna be placed, right? You can do it manually, meaning you can put anywhere, or you can use the presets, so it's like perfectly in the middle. So we're gonna use the preset for the top middle there, and then as a child of the panel container inside panel, we're gonna have a VBox container. Oh, sorry, a HBox container. Oh, I can't type. HBox container. This is gonna arrange all of our childs like next to each other, so like in like columns. So we're gonna make the alignment. We can do center, and should be good. And then okay, yep. And then over here, before actually we start, um, make sure that fuck, what's it called? That oh my god, went blank. It's okay. Don't worry about it. Actually, um, we're gonna go here and we're gonna start building it. So we need a couple things. We're gonna need 3 labels, right? We're going to need a player score label, right? Player score label. We're going to need a timer label. Label. We're gonna need another label called time, where we can see how long it's been since we started the game, and we're gonna need an AI score label. Oh, my bad. Label. Oh yeah, over here it also shows the recent nodes you used. It's a bit easier to access it actually. Oh, wait, we do not want this there. Okay, and then a AI score label. So here we can. Actually, before anything, here on the HBox container, guys, click on it. Okay, and then you're gonna go to layout, and then over here where it says custom minimum size, make sure that you guys make this like a bit bigger. So I don't know, I can make it like no, it's just too much. I don't know, like Doesn't really matter what size you make. Just make it whatever size you want, I guess. Um, and then inside of it, we're gonna have the for the player score is 0. Um, for the timer, we can also just have 0 here, and then for the score is 0. Okay. Let's make the actually you don't actually need this. Sorry, you can just take out the minimum size. We're not gonna need that because another feature of the panel container is that anything that's within it, it gets auto adjusted so it fits like correctly. So all we're really gonna do, like, which is reasonably easier, let's just go into the labels and you're going to go to theme overrides, font sizes, and then you're gonna choose a font size. Whenever you want to do any font size stuff or you want to change any like label settings, you're essentially always gonna go to theme overrides and then you're gonna change it here. Okay, you're not gonna change anywhere else. The other settings, they don't necessarily change the actual text. They change the node, but the way the label node works is a bit weird. So you need to actually change the text itself, not the node. So you're always gonna go in here. So font sizes, we're gonna make it. Let's make it a bit bigger. 64. For the time, I think I'm actually gonna make it like in the middle. Make it like 32 for the size. And for the AI score, we can make it 64 as well. 64. Okay. And then there's another node that we're gonna use. It's called a vertical separator. So essentially what that does is like it basically makes a vertical line. And we can just spam them here and then put another one here and just they're used to separate things, so you see. And then the cool thing about them is that you can kind of like change their you can change their width in the minimum size, so you can spread them out. Obviously this is probably not how like we're gonna do UI because it's a bit ugly, but you know, this is how some of these nodes work. So there we go. So
How do you move the vertical separator?
what do you mean move?
Like, didn't you like move in between the zeros or no?
No, you can just like you just put it in between the labels.
Oh, okay, I
See
see.
how?
Oh, I see, I see, I
Yeah,
see. Okay.
we're actually going to have one more here at the start and at the end, so it has like a little gap. You see, it looks a bit nicer. Um, but yeah, so we have that for our scoreboard. Okay, so there's also a couple other things here we're gonna do. So we're going to make these labels accessible as a unique name. What that means is that whenever we're looking for this label through code, we do not need to specify a path if we can just put the name and we can just put the name in. So because that works because whenever you put a percentage, so we're gonna turn this on. So now whenever we try to access it in code, all we need to do is get the node. You're gonna see it later, and we're gonna do percent and the name of the node. This lets us be able to access nodes without actually having the path for them, as long as they're in the same tree. So very important. This works as long as they're in the same tree. That's it. So we can actually go here and we can add this to our game now. We can add our UI. So let's go here. Let's go to our UI, and we can just put it like about there. I don't know. Yeah, there we go. Okay. So I put our UI there. And there we go. It's in the middle. So now, I mean, this is essentially our entire game. So now we're gonna start coding. So first of all, I think we can start. Let's start by adding our which one? Let's make our player script first. I think that would probably be the best one. So yeah. So starting with our player script, we're going to right click on the player scene here that we have in our game, and we're gonna do attach script. Then we're gonna make a new C# script. Remember that, and we can name it. We can name it Pato. I would just name it player actually. Just name it player. We're gonna name it player, and then that's going. And now let's go to our split view again.
Hold on, one more time how to make the new script. My bad, bro.
No, you're good. You right click on the scene and you just
Okay,
attach
right, right.
script.
Oh, okay. And this is for which one? Player?
We're doing the player one first. So now within our player, there's a couple things that we need here. So first of all, you can tell here, see player and it extends the static body 2D. That's because the root node of our scene is a static body 2D. That hence he extends that node. So first thing we're gonna have here, we're gonna have a constant double, or this is
Wait, hold on. I'm.
yeah.
You said extend script?
No, like we don't actually have to type extends, but like this like means like that
Well, no,
the
because like I don't know, it didn't like pull up C sharp for me. I don't know if I'm doing this wrong, but like so I right click on player and then
when you press attach script, he asks you if what the language is. You have to make sure you select C sharp.
oh C, okay, and then you just named it player paddle.
You can name it whatever you want. Just make sure you know
Okay,
what it is.
I see. Oh, okay, I got you. Okay.
Okay. So now within there's a couple of variables we're gonna need. One is the speed of our paddle, right? This is actually gonna be the same speed we're gonna use for the AI later. So for right now we're just gonna make it 500.0, and then we're gonna some more variables. We're gonna have a private color rect paddle. So this color rect paddle, what this is referring to over here, if we go to our player was paddle, yeah, paddle. If we go to our paddle, it's referring to this node right here, color rect. The reason we're gonna need this node is because we want to make sure that we can move up and down, but we do not want to go lower than the top and the bottom. We don't want to pass through them, right? We want to like hit it like it's an actual wall. So we need the size of it. So to get the size of it, we need a reference to the size of our color rect that's over here, the size you made, you know. So that's why we're getting this variable, and then we're also gonna have a private float screen height. We're gonna use this later. You guys will see, and a private float paddle height. Well, actually, paddle like because we're gonna use half. We only need half of the height, so we're gonna use paddle half height. And then after that, that's it. And then we're going to make a ready function. Override void. So a ready function in Godot is a function that runs instantly whenever your class or scene gets instantiated. So whenever you add this to a scene and you run the scene, this whatever is in ready is gonna instantly run. So it's kind of like an init function in Python or a constructor, not really a constructor, but like a main method in Java. Um, that would be like the I guess equivalent to like a ready function. So first thing we're gonna do here is we want to actually get that paddle, right, that we're referencing here. This type is colorect because that's the type of the node that we're looking for. Here we're trying to get this node, which is a type of colorect. So paddle, we're gonna equals get node. This is essentially how you get all nodes in C# Godot. So you do whatever variable you're gonna host the node in, make sure it's the type of the node, and then you do get node, and then you get a type, right? Inside of this is the type, colorect, and then you do parenthesis, and then the path. This is the path to the node that we're getting. So because this is right under our root, we can just say colorect because he knows that like, okay, this is a direct child of the parent, right? Which this is the parent class. It's coming out of the paddle, right? So we know it's called colorect because that's the name that's right here. So that's the path. And then we're also going to set the screen height, which is equals to get viewport, right? Get viewport rectangle or rect dot size dot y. So we're not actually getting the actual screen height. Well, we are getting the screen height. We're getting the y value of the viewport, which the viewport, if you guys make sure you guys know the terms, it's the screen that we talked about earlier. This entire thing here, this is the viewport. So when we do get viewport dot size y, we're getting the y value of this. And then we need to get the paddle half height. So that's going to be the paddle.size.y, right? Divided by 2. This just makes it a float, by the way, the f. Okay, And then that's all, everything is gonna be a ready function. And then there's another type of function. It's called physics. Oh, sorry. It's called physics process. So physics process runs every single. It runs every physics tick. So the difference between a physics process and a process is that in physics process you'd have things like colliding with walls, collisions and whatnot, and like things that involve actual physics, right? Like gravity and all those things. In process, it's more like you're just doing calculations that need to be calculated every single frame. So, for example, like um, how many bullets is in the gun? That would be something that would be in the process and not in the physics process, right? Or like, is the player dead? Um, Although we'd probably approach another way, it's something you'd use in process, not physics process, because you're just checking it every second. You're not actually updating something in physics. Um, in this case, we are though, because we are updating the position, and we need to use delta, which is the amount of seconds from the previous frame. That's like the accurate definition, but yeah. So what we're gonna do if statement here, input dot is action pressed, is action pressed, parenthesis, and then we're gonna name and we'll have it up. Okay, if you guys remember at the start of the project when we set up our input map, we had two actions, up and down, one with W, one S. So that up right there is what we're using here, up. So if action presses up, we need to make sure we move our position right up. So position equals new vector true. Vector true, by the way, is just essentially like coordinates in Godot. Yes, they are actual vectors, but certain things like position, they are seen as vectors, even though like that might not exactly fit like a vector like uh, definition by like a physics
Oh, can
professor.
you like a second like catch up?
Yeah, sure.
My bad. Oh, my bad, guys. I'm sorry.
No, you're good. I'm also gonna be recording it too, so you can always go back on it if anything.
Yeah. Input dot is action pressed.
Mm-hmm.
Position equals new vector. Is that a 2? Or new vector 2?
Yeah, new vector true.
Okay.
All right, so we're gonna make a new vector 2 for the position, or well, not new, but we're assigning a new value. That vector 2 is gonna take a position dot x, right? Which we're not gonna change since we're not going sideways, and a position dot y. Okay. Um, in Godot, if you guys notice very closely, there's like a ruler, right? If you go to the left, that's positive. If you go to the right, if you go to the right, that's positive. If you go to the left, that's negative. Normal. But when you go up, that's negative, and when you go down, that's positive. So the y-axis is actually inverted in Godot. Don't ask me why. I have no fucking idea. It just is. um, so whenever we want to go up, we have to do the current position, right? Minus minus the, I guess, length of where we're going. So in this case, we're gonna be using our speed variable, right, times delta, which again, delta is the time elapsed between frames. So this is gonna ensure that no matter what computer you're at, it's gonna run the same way. If you don't use delta and like you just use a number, because process and physics processes occur every tick, different computers have different tick rates because they're different machines, different CPUs. So some may be slower than others, some may be faster than others. So how do you actually make sure that all the game runs the same in every machine? Is you multiply by delta, which makes it not multiply by a number, but by the difference in tick rate. So it basically makes it equal in every machine. That's like the simplest explanation. Like, it's kind of complicated, but yeah. So you do that, so it's equal, and then if it's not up, right? If we're doing down, so if else if um, input dot is action pressed um, down, right? If that's the case, we're going to. I'm just gonna copy paste this for speed, but we're gonna update the position again. Um, this time it's not gonna be minus though; it's gonna be plus because remember, down is positive and up is negative. So keep that in mind. And that's it. And then outside of that, now if it's neither of those, we just make sure that the position basically stays within the game. So we're gonna make it a bit different. So it's gonna be so now we have to make position dot equals new vector 2. Position x stays the same, but in our y here, it's gonna be different. We're gonna have a clamp function. A clamp function basically says that okay, you cannot move, but you can only stay within this designated y values in our case. Okay, so we're clamping our position dot y. Okay, and then we're clamping it between the paddle half height and the screen height minus the paddle half height. Honestly, I don't think there's any way I can like visualize that unless like I draw it, and I'm not gonna draw it. So I think the easiest way, like, if you want like a in-depth explanation of what I did here, either try to draw it yourself, or ask like Google or something. I don't really want to draw it, so I'm just gonna leave it at this. Essentially, this is clamping, where our thing is gonna be between this pink line and this blue line. That's what's happening here. So this is for our player script, and we can actually over here in our game. Okay, our player has a script now. We should be able to actually run the game and see if that's working. So
Hold on, give me. Does that say screen height minus paddle
yeah,
half height?
yeah.
Okay. Screen. Okay. Why is there three parameters? Like what?
Yeah, so okay, so the first parameter, um, position Y, that means we're clamping the Y position. Okay, that's what we're clamping. When you hear the word clamp, like literally think of like a clip, like where you like clamping, like papers or something.
Okay.
So position Y is what we're clamping, and then this first variable is what's it called? It's like these are like the borders from where we're clamping. So we're clamping the half height to the screen height minus half height, meaning that overall, whenever we make this position, it has to be inside of this. It has to be like between the height of the half of the paddle or the entire screen. Essentially, you can't go over it. So
Okay.
when we run it, you're gonna see. You should be able to move your player with W and S, by the way, up and down like this. And okay, yep. So you can move it.
I can't move on. I feel like I'd definitely mess something up.
Did you assign the things earlier?
Oh, can I see your code?
Hmm.
Oh, I'm stupid. Hold on. This is it. Wait. If I make a change, does that like save when I run it next?
It should, yeah.
Still doesn't move.
Did you in your input map? Is your input? Did you do your input map at the start?
Yeah, I did that.
Did you name it up?
Well,
Did you put capitals?
I did I lowercase.
Okay.
I don't have any. Let me just see what your code looks like. Oh wait. Is it case sensitive? Yeah, right.
Yeah, it is.
I had my like X is lowercase, maybe that's why. No, it's still fucking nothing. Should I like share my screen or something? I don't.
Sure.
This is what my code looks like, but I don't.
It looks fine. Open your input.
My input map. Okay.
Mhm. Wait, are you running the paddle or are you running the game?
I'm just clicking right here.
Click game.
Yeah.
Oh wait, oh sorry, I wasn't looking at screens. Realized I'm trolling. Um, where is you? Okay, and it's not running. You can't like
No.
move it. Okay. Click the input map.
Mm, okay.
Okay, and then let me see your script again.
Oh my God. Is this it? Maybe.
Maybe try to run it.
No.
Press the hammer real quick, like before you run it. Hmm,
No.
that's weird. Um,
Oh, is it supposed to be capital I?
yeah, yeah. Oh, I didn't realize. Yeah, you didn't have it a
Bro,
capital.
I am like, I actually might be so slow right now, bro. I need to grab an energy drink or something.
It's okay.
I need to click build, right?
Mhm.
Fuck, hold on. Nope, still not going.
Uh, wait, go back to your code. Input presenting 52. Hmm, that's weird. Not sure. I mean, you have everything.
I'm like, I don't know if I'm like, oh, it's like a naming thing. Maybe like I was like naming these things wrong, but I really don't know.
It's something, but I mean, oh wait, it's so okay. Get viewport rect. It's a method, so you need the like
What?
parentheses. It's a method.
Around it?
No, no, like at the end of it, like it's a met. Like the get viewport rect. It's like a method itself.
Oh, so I have to go like this.
No, no, no. Like just the get viewport rect. Yeah, there. And then what else do you have? I'm not sure if that's it, but if that's only it, but That's one thing.
Oh,
And
yeah, it's not
wait,
working.
there's like wait. Okay, screen heart. Um,
My bad, bro. I don't even know why all this is happening.
yeah, I'm not. I mean,
If you want, you
all
just
of a
like move
sudden.
on, and
Oh,
then
okay.
I'll just figure it out, I guess.
After I'll like help you fix stuff. Don't worry.
Okay.
Okay. So we're going to have here as where was that? So okay, so this will basically be it for the player. Actually, let's just make sure that we do this on the paddles. Let's move the thing here like more to like the middle, so where the pivot points like in the middle of it. So boom there. So you see like now the pivot points in the middle. Just makes it a bit easier for like the game know the sizes and stuff. And then run it. You're gonna notice that like see like I'm even though I'm holding W, I can't go past the top of the screen, and I can't go past the bottom of the screen. So that's what clamp does. So now W and S should be able to move it. So now we're gonna work with our enemy. So we're gonna add our enemy script here. So for our enemy script, it's actually very similar, kind of a little bit. The difference is that we need some other things that we'll be doing. You see. So let's start by attaching a script to it, and then we can just call it enemy. Um, just like enemy script, enemy paddle, or just enemy is fine actually. So enemy, and then inside the enemy, we're gonna have one new type of variable that we haven't used that. It's called an export variable. We're actually gonna use these exports a lot. So essentially what they do is over here in your inspector, you see how there's so many variables you can choose? You can actually put whatever variable you want into here as like a custom variable in your inspector. So that's what export does. What we're gonna be exporting is we're gonna be exporting a reference to our ball. Okay, so our enemy can track the ball, so it can kind of like it's not gonna think, it's not like a full-on AI, but you know it can track the ball, so you can play against it. So we're gonna export a private character body 2D because that's the type of node our ball is, and then we can just call ball. And then once we save that, if we rebuild the project, you're gonna see here enemy. Now we can actually assign a ball variable, and then it's asking for a character body 2D. So when you press assign, it sees okay, this is your root, and these are the character body 2Ds you have in your root. You can assign one of these. So it's letting us assign ball. That's what you want. So we assign ball. Now our enemy has a forever reference to where this ball is, or not to where that is, but to the ball itself, right? So we have that, and then we're also gonna need again speed, constant, double speed. We're gonna make that equals 500, so it's the same as our player. And then same thing with the player. With the player, we're gonna have a color rect, paddle, and then we're gonna have. I'm just gonna copy paste actually. These, so we're gonna have these two as well, just like the same thing we had with the player. These four, same thing. And then we're gonna have another ready function. Actually, the ready function is also gonna be the same as our player because you know that's like all we're really doing here. Wait a minute.
It's giving me like errors when I try to do the double speed thing. Constant. Oh, is it speed equals 500? Oh,
Oh, I didn't even do
I
different.
see. Yeah, I see it in my head.
Okay, so have our. This is the same thing as well, because all it is we're getting the paddle, or you know, we're initializing the paddle reference. In this case for the AI, we actually don't need to initialize, as you see, like we don't need to do paddle.get node ball because that's what this is for, right? So we can just drop the ball there. So now we don't even need the we don't even need to initialize it. We just have it it just works. It just does it by itself. So we have that there, so that's good. And then now in our physics process is what's gonna look a bit different. Avoid physics process. So now physics process, we're gonna have a direction, right? That variable direction is gonna be the ball dot global position, right? Dot y minus global position. Oh, global position dot y. So this direction is the direction of where the ball is, right? So this is so our enemy can track the where the enemy is and where the ball is, and he can keep track of where the ball is, right? So think of it like an arrow, and that's pointing to that, okay? And then we're gonna do if, right, the direction is greater than 0, then we're gonna update the position of our enemy. The position is gonna be the same like kind of initial thing. Position equals new vector true. Position dot x is not gonna change because we're only moving it y.
Did I
Position.
say DLR for var?
Yeah,
Oh,
dir
DIR.
for direction. You can also name a direction if you want. So we're gonna do position equals new vector true. Position x, and then remember that if it's positive, that means that we're going down. Okay, so so we have to do put it positive. Oh my God, position dot y plus float. Oh, what the fuck? Float speed times. Again, remember the delta thing, so make sure it works on all machines. Delta, and then we can close that. Oh wait, I think I put an extra. There we go. Okay, and then else, right? Else if direction's less than 0, we're going to update the position again. Same thing, but instead of plus, it's position y minus the change. And then outside of it, we have to constantly just make sure it's clamped.
Is this the same code as the previous one?
It's not the same exact, but similar.
Like for like the position equals vector 2?
Yeah. This is like basically
Okay.
this is the same thing.
So you just copy and paste it.
This one, yeah. But
Okay.
just it might be. It depends on like this part is gonna be different. So position x, we're once again clamping it just like we did earlier, right? Dot clamp. And then we're gonna do mef. Except that this time, sorry, this time what we're clamping is not actually because we're not moving ourselves. The computer is moving it. So we need to clamp it within the walls, but also like so the whenever it does move, it's like smooth. So there's a function for that actually built in. It's called mef dot mff dot move toward. Okay, so move towards, it moves toward true by delta value use negative, which means when it's moving, when we're updating the thing, right, when we're updating the position, it does it using delta, so it's smooth. So that doesn't break our shit. So we're gonna use move toward position dot y, and then ball dot global ball dot global position dot y and floats speed times float delta. So that's gonna make sure that it moves towards wherever the ball is in y coordinate smoothly. Okay, so we're clamping between that and now we need our other two variables. Remember the paddle half height and the screen height minus the paddle half height. That's this part's like the same ones we had earlier, like that. And then so now wherever the ball is, we can't really test right now because the ball is up here, so it's not really gonna move. But we'll test it eventually.
Hold on,
So
can you just give me 1 second just so I could catch up again? Because I'm.
okay.
I'll just take a picture, bro. I'm not gonna slow you down. Just try to
Okay. It's
keep
also
up with
again
it.
like I'm gonna literally as soon as it's done, I'm just gonna post it so you can rewatch it and pause it and do all that. So don't worry.
Okay.
And then I'll be in call if you need to ask any questions after it. Um, okay. So we can test this. Let's do this. Let's manually just move the ball here. Okay. If we move the ball here, we expect the enemy to whenever we start to be like around here, right? So let's see. See if it works. Um, there we go. See, you moved smoothly to where the ball is. So, and then we move with the ball here, and we start, and boom, it moved over there. So we know that our enemy is working. That means our enemy can now successfully destroy us a Pong. So, what we do now is, now we're gonna put our script into our ball. So our ball script is probably gonna be the longest script because there's a lot of factors to the ball. So follow up with this one, guys. This one's very important.
Yo,
So there's a
I think I'm gonna have to cut it short because I gotta go.
okay,
But
that's fine.
I'll watch the video.
All right. Bye. So we're gonna make a new script, C sharp, and we can just call it ball as well. We'll go here and put it under scripts. Oh, sorry. There you go, scripts. Oh, I've been making everything in scenes or whatever. You guys get it, I think. So, okay. So we have our ball script here, and over here on the right. There's a couple things we're gonna need. So one, we're gonna start actually using our events that we made earlier through our event bus. If you guys remember these events, we're actually gonna start using them. So I'll show you how to use them. So first thing you do to use the event bus, you need to have a reference to it. So private event bus, you need to make an object, right? Event bus, you can just call it whatever you want, but let's make the names a bit easier. The type is the name of the class, and then the name is the name. And then we're also gonna have a couple other variables for our ball, which is gonna be a private double speed, right? Which is we're gonna make it equals 450. And then we also have a private double. We have a couple things to keep track of time, so we know when to speed up the ball. So we're gonna have a timer that's every 5 seconds he speeds up the ball. So time until next speed up. We're gonna make that every 5 seconds. So there you go. And we're gonna have one more private double. Actually, this is gonna be a constant, so we can constantly check it. Because this variable is never gonna change. We can just call it speed up, speed interval. Okay, which is 5 seconds, right, between each speed. That's the interval. And then that's set for the variables we're gonna need. We're gonna need our ready function that, remember, it runs the moment it gets initiated. Yep. Within our ready function, we are going to do the most important step for event bus. So the most important step for event buses that you're also gonna use in the project, whenever you're using your event bus, there's two things you need to do. One, you need to put a reference to it here, private event bus, okay, in your script if you're gonna use it with the events or make events or whatever. And then second, you need to actually you need to get the event bus. So event bus equals get node type event bus, and then it's gonna be /root/event bus. So the reason that we're doing this is because, as I said earlier, in Godot, when we make something global, it becomes part of your direct root, meaning any file in your system can access it because every file in your game has access to the root node. So because of that, we can just do root/event bus, and this is gonna work no matter what every single time. So this is how we get our event bus. And then another thing we're gonna do is we're gonna use something called groups. Groups in Godot is a way to put nodes or scenes in kind of like boxes, okay? So other nodes, they can use a method called isInGroup to check if whatever node is there is in that group. So we're gonna use the groups to figure out if whatever entered our goals, our player goal or AR goal, is a ball or not. So what we're gonna do is we're gonna do add to group, right? Whenever this starts, we're gonna add this ball to the group, add to group, and we're gonna call ball, just ball. Okay, that's the name of the group. And that's it. And then we're going to get our event bus. Okay, actually, let's do this first. Let's make these other functions first. So that's basically the entire setup for now. There's a couple other functions that we're going to be using. So let's start here. So in the public override void, now we're going to use a normal process method, which is not a physics process, it's a normal process. And this is so we can keep track of the time in the collisions, okay? So we can do time until next speed up minus delta. That means that every frame, this is going to update, and eventually it's going to get you 0 or less than 0. Whenever that gets less than or equals to 0, okay, less than or equals to 0, we are going to speed the ball up by 1.5, like the speed. So by by 150% the speed. So we speed up the ball, and then we do time speed up, next speed up. We're gonna plus the speed interval. This is basically us resetting the timer. Okay, so we're resetting this back to 5. So now it's gonna start 5 again, and 1, 2, 3, 4, 5, speed up. 1, 2, 3, 4, 5, speed up. This is what this is doing. And then we are gonna update the velocity. Whenever we do speed up, we have to make sure we update the velocity, because otherwise our speed is not gonna get updated. The update velocity, we can actually just make a update velocity function here. Public void update velocity. All this function is gonna do is it's gonna say velocity equals velocity dot normalize. This essentially normalizes the vector times float speed, and then this updates our speed here with the new speed that we got. So that's all it's gonna do. And then now, we're still within our process function, we need to detect whenever it hits a wall, right? So var collision equals move and collide. That's a built-in method in GoDot for character body 2Ds. So move and collide, meaning that it can detect collisions. And then that takes in a velocity times a float delta, which is like, again, the time between frames that we need to make things look smooth. So this is our collision, and then with that collision, we're gonna say if collision is not no, meaning that it hit something, right? If it's not no, that means it collided with something. We're gonna actually bounce off that collision, right? Like whatever it hit, we're gonna bounce. So we're gonna do velocity dot bounce. When we do velocity dot bounce, Godot automatically is able to get the next vector that's supposed to go to based on the physics engine built into Godot. So, which is great. That means we don't have to write our own physics engine, right? We do velocity equals velocity dot bounce, and then it takes in a collision dot get normal input, which this returns a vector 2, which basically just returns the like vector of the body that's colliding with. And then this is it. This is it for process. This is it for update velocity function. Now there's 2 more methods that we need, and is a method to move the ball, right? There's public void. Actually, we can make this.
You need a separate update velocity function.
Huh?
Why do you need like a separate update velocity function?
You don't technically need it. You could just like put this here. But like it just makes it a bit cleaner. It's up to you. Like you could, do
Okay.
this. But if someone has to later go and make like add extra functionality to update velocity, then this will be better, because then now you can just add more lines instead of here you'd have to manually like that. That's gonna make code very cluttered. So I'm trying to like keep it as clean as possible so it's easier to understand. So we're gonna have a function here called move ball, and in this function we already have their speed here, so No, sorry. Oh my god, I'm tripping. This function is actually gonna be called. We're gonna call this function whenever we restart the game, and whenever we start a game. So when the ready only runs one time whenever it starts, right? So that means we can just call move ball automatically here at the start. So boom, it's gonna start moving the ball. And then we're gonna actually connect one of our signals here. So we're gonna connect our restart game event event handler. We're gonna connect this event to the to move ball. So whenever the game restarts, whenever something in our code tells the game to restart, we're going to run the move ball. So the way we do this is we do event bus, right? Remember this is the name you made up here. Dot, and then the name of the event that we want to connect. So in this case, it's restart game, right? Remember, the name of your event is not restart game event handler. It's just whatever you put before event handler. So in our case, restart game. And then you actually use this. You use the plus equals notation, which it's it makes a bit more sense when you think about it in a different way. But for now, yeah, just you use the plus equal notation, and then you put the name of the method you're connecting it to, which is moveBall. There you go. So now, whenever restart game gets called somewhere in our code, it's gonna go here and it's going to automatically call moveBall. Okay. And then we also want another thing to happen, which is whenever we're gonna we're going to use the restart. We're gonna connect the restart game as well to something else. We're also gonna connect it to a lambda function. So the reason we're connecting to lambda functions because I don't want to make an entire new function for this, and we don't really need to. So the way you do lambda function and you connect to it is you just do event bus restart game normally, the plus equals normally, and then you do a parameter list where you could input a parameter here if you had one, and then a arrow notation, and then you open like this. Okay, so kind of like an actual method, and then you make sure you put the semicolon there at the end. And then inside of this method, all we're doing is we're doing time until next speed up equals speed interval. The reason we're doing this is because even though we're restarting the time until next speed up over here every second, if the player or the AI scores, I don't know, 12 seconds, we still need to restart the timer no matter what. So this is what this is doing. It's restarting back to 5. Okay. And then that'll be it for ready function. And then we can actually work on our move ball function here. Here we're gonna set the speed that we have back to 450 in case it's not 450 whenever we enter this function. Since this is restarting everything, we're doing times to next speed up. We're again just making sure it's the same interval, right? And then we're gonna make a new float direction x equals, so our direction x float is always gonna be 1, okay? Because whenever we spawn the ball, we don't want the direction to be anything different than 1. Like 1 is okay in general. Or I mean, if you want, you could make a random between 1 or -1, but then you could get numbers between, which means that like your ball could go straight up, and that would make the game kind of boring. So I think 1's fine. That's only gonna start in one direction, but that's okay. It's gonna bounce anyway. So, and then direction.y, it's gonna be a float as well, but this time we're gonna use a GD script, not GD script, but a GoDot method, which is gd.randRange. This is their random number library, I guess you call it. And then we're gonna get a random number between -1 and 1, right? So you randomly chooses a direction in like the y space. So then if the direction y is equal to 0, we don't want this, because if that's the case, then it's not gonna move. So we were going to re-roll it. So we're just gonna copy paste this, and we're just gonna do it again. And then that's basically it. And then we're gonna make a vector2 direction where we're gonna combine both of these directions that we made. So new vector2, and then we have direction x and direction y. And then we gotta make sure we normalize it. If you don't know what normalizing vectors are, just search it up on Google, normalizing vectors, and you're gonna get a very good mathematical explanation of what it is. Here it just says returns the vector scale to unit length. It's more detailed than that, but it's not something you really need to know. You just need to do. If you want a deep explanation, though, search up vector normalization or something like that. And then we're gonna update the velocity as well to equals our direction times delta. Well, actually times our speed. Sorry, times our speed. There you go. And then that should be good. And then another thing with events that we haven't done since this is the first time we use events, there's some major things we went over. So you have to initialize an event, right? Which is you use our event bus. You remember class name event bus. That's the type. So you do private event bus, the name that you're going to refer to in the file. You have to actually get the node, right? Which we do this by doing event bus equals get node, the type, and the path, which is always going to be in root event bus because it's in global. This, by the way, this line applies to our project as well. It's going to be the exact line in our project because it's the exact same way that we're doing it. So yeah, and then another thing that's very important for event buses is that at the end of your file, if you are using event bus, you need to make another method called exit tree. So this method, okay, whenever this ball gets deleted, okay, in Godot, if you're using signals in Godot with GDScript, it automatically handles the garbage collection. The garbage collection system automatically deletes any signals that are no longer used. In C#, however, that does not happen, meaning that you have to manually delete the signals. So to do that, all you have to do, it's very easy. You just do event bus minus equals event bus dot restart a game, because that's the event we connected here, minus equals move ball, because that's the method that we actually connected to. There we go. And then this is everything for our ball script. Sorry, I was answering something on Discord. Okay. So, and then this is everything for our ball script. So now, I mean, we could run it, but it's not really going to do anything because our ball is up there. So even if it goes somewhere, we're not going to see it. So now we're just going to go to let's do our AI Go now. So now we're going to go to our AI Go. So let's make sure here. Actually,
I
yeah.
I kind of like I need to go like very soon.
Yeah,
Like,
that's
is it
fine.
cool if
No,
I
that's okay.
diff? I'll watch the video and I'll catch up to speed and everything.
That's totally fine. You're good.
I'll catch you later.
Alright, see you, bro. So now we're gonna do our player Go. So what we're gonna do is we're gonna attach the script to it, and then C# again, and we can just name it player Go. And then inside of the player Go, again we're gonna be using events here, so we need to make sure we have our event bus. Event bus, or I mean, I'll just call it event bus. Event bus. And then that's basically it. We don't really need anything else for it, honestly. We're gonna have our override void ready here. And we're gonna do event bus equals get node. Event bus, same thing as we did before. And then this is a bit different though. What's it called? Although we're not gonna be subscribing to a thing, we're gonna be emitting signals from here. So we are going to connect, however, a built-in event that happens in Area 2Ds. Area 2Ds have some built-in events that you can actually look at if you go here, and then you click node. You see where it says signals. Any of these signals in any node, there's multiple nodes of this, by the way, you can essentially just you can use their name here and it works as a normal event. So for example, one of the signal we're going to be using is it's a body entered, right? So if I want to use a signal, what I do is I'll go here in my code and I do like before, body entered plus or minus, and then I can put it to a function. So I'm going to call it on body entered, okay? Like that. We don't have a function yet, so let's just make it here. Private void on body entered takes in a node2d body. Okay, and then when we do that, now this signal is connected to this. The reason we don't need to do event bus is because this signal or this event is not actually one of our custom ones. This is a built-in into the node, so it knows that it has this signal already. So yeah, and then in our body entered, we're gonna check if body dot is in group, like I talked about already, the group things. And then if it's in group ball, aka if it's our ball, what happened? We're gonna do event bus dot emit signal AI scored. Boom, that's it. So and then we can just return. So whenever a body enters our player go, this one on the left, if the body is in group ball, which we added here at the start, add to group ball, we're gonna emit a signal AI scored. When we emit the signal, our UI, although we haven't actually done it yet, our UI is gonna get that. Is going to get the signal by subscribing to it, which we're gonna do in a bit, and then it's gonna do something based on that. And then that's it. And then we just have to make sure that we also have our exit tree function, where we just go body entered on body entered. There you go. Save it, and that's it for our AI go. Where is it? Oh, yeah, we didn't make it. For our AI go, we can attach a script. AI go. I haven't been putting it to script. I'm sorry, guys, but hopefully you guys don't get lost. Well, this is a good example on why in our project we have so many files with different things. You see, like it can get very cluttered, and especially when you have a lot of files. So that's why we have that. So now you guys understand. Oh, we put it in the wrong place. Here, script. Okay, there we go. So AI go. Our AI go is gonna be essentially the same thing. Here, I'm just gonna actually drag all of these. Actually, no, it's fine. It's fine. It doesn't really matter that much. So for our AI go, it's essentially the same thing. We can honestly just like copy paste this into our AI go. The difference is that it's not gonna emit the AI scored, which is this one. Oh, it's AI scored. It's going to emit player scored, right? So, oh shit, player scored. It's gonna emit player scored. So then there you go, same thing. And yeah. Now we're gonna move on to our UI script. Okay, which it's a bit long, but it's okay. It's not that bad. And then now we're gonna go here, touch script. We can just call it I don't know, UI script. Oh, I didn't put in wrong. God damn it. Wait, what the frick? I have two. Wait. Okay. Okay, yeah. Let me just actually make sure these are on here. Okay. 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 Okay, so right now we're working on our, sorry guys, we are working on our UI script. Okay, so UI script. Okay, so in our UI script, again, we need our event bus, right? Event bus, and then private label. In this case, we're gonna have our labels here. Oh, private label. We can name a player score. Private. Oh, let's look at our scene by the way, so you guys have an idea what we're doing here. So remember here how I said that. Oh, I actually need this. So remember when I said that this allows us to access it within the UI. So that's why we have that right there. We're doing label, and then this one's gonna be the AI score. This is what's gonna hold these two things here, and then yeah, and then we're gonna have our scores themselves here, integer player score, which is gonna start at 0, and then private integer AI score. It's gonna start at 0. How long have we been here for? Okay, I think we can finish it in 2 hours flat, so that's good. And then we're gonna again have a public ready function, public override void ready. Event bus equals get node. Remember, same thing, same process for the event bus. Event bus, there you go, and then event bus dot AI scored. So remember, this AI scored is the, where is it? Here is this here, right here, these events. Yeah, we're gonna be connecting both of these to our UI, so every time that these are fired off by our goals, right, that we're emitting them, we will be getting them and applying them to our UI, so we can change the text in the UI, okay, updating the score effectively. So we're gonna attach this to our AI scored point method, okay, which we are gonna make, and we're gonna attach this the player scored to our player scored point method that we are gonna make. So now we can actually initialize our player score variables, the labels, right, to get node as well. Get node label, and because we have them as accessors like this, I don't actually need to put an entire path. All we need to do is do percentage and then the name, player score. That's it. That's how we get it. And then for the AI score, same thing. We do this, get node, label is the type, and then we do again a string, right? Percentage, and then AI score, the name. Yep. Guys, I promise, like, as you guys start coding more here, you guys are gonna get so fast, like, you're gonna get so quick, and then you guys are gonna be happy, and then everyone's gonna have fun, okay? Please, I hope if you made it this far, I'm sure you're trying, and I just want you guys to know that, like, I believe in everybody. I think this is a project that can 100% be done in 9 weeks, and I think everyone can learn a lot from it. And honestly, I wouldn't doubt it if you guys would become freaking game developers after this, because you guys are gonna like it so much. So the dopamine at the end is gonna be worth it, guys. I bet you guys. So now we have, okay, so we have the labels, we initialize them. These is red because we still haven't made the functions. We're gonna make the functions, just give it a second. And then this is, we're doing AI score the label dot text. This property allows us to change whatever is inside of here. See, where it says text, you can actually hover over it. It says property text, that means we can use it. And then we would just get the score, which is this number, and we're going to use a toString to make it into a string so we can put it in this text. And then that's essentially it. That's what's in our ready function. And then now we need to make two functions. for when the AI scored, right? For AI scored point. And then all we're gonna do is we're going to update our AI score plus plus. That means we're adding 1 to it, and we're doing AI score dot text again. So we're this essentially, and then we just copy that, do that again, and then we need to event bus dot emit signal. And what are we emitting? We are emitting the restart, right? Because think about it. If someone scores and then they get signal, okay, boom, the guy scored, awesome. Okay, so we update their score. So what now? Now we restart the game. So that's where we use a restart. So we're going to do essentially the same thing for our player. So player, there we go. So our point, and in this case here's player, and then this case here's player, and this is player. Same code, guys, just same thing. Again, we need to restart the game after one of them has scored. And the most important thing, so we do not have Stack Overflow, not Stack Overflows. I forget the name of the error now. I went blank. It's okay. So our game doesn't crash. Is we make sure that we do event bus dot AI scored, and we disconnect it, guys. Please make sure you do that. If you guys don't do this, it is something that unfortunately I'm gonna have to reply in the PR and be like, sorry, but you need to disconnect the signals. Please check that. Player scored point. Disconnected. Boom. That's it. That's our UI. So now we should be updating the UI when we play the game. And yeah, now there's only one more script to really do, and that will be our game itself, the actual controller of this whole thing. So we're gonna make a new script inside the scripts this time, and then we can call it game. That's fine. C#. And now, actually no, guys. Before we do that, we're gonna do the script for our time first. Okay, this is gonna be really quick. So we do time script, new time script. This is, by the way, this is inside your UI scene. All right, guys. We're gonna make a new script here for UI for the time. Then inside our time, all we're gonna have is essentially, again, we're gonna have our private event bus because we're gonna need event bus. Event bus, and then we have our override public. Ready, right? And then inside of this ready, we're gonna get a node, event bus, okay. And then remember, and then we're gonna be connecting the restart game to a lambda again. But this time I'm not gonna use, it's just one line, so I'll just do this. So what we're doing here is essentially we are setting the time to 0. Okay, guys. That's what we're doing. And actually, we need one more thing here. Should be the public double time. So this time is what time? This is the time that's gonna show up here in the middle. Okay. So it's gonna start at 0, and then every time the game restarts, we gotta make sure obviously the time goes back to 0, right? I think that makes sense. And then we need one more, and I think you guys guess what this one is. This one is the process, so we can actually keep track of the time. So we're gonna do time plus delta. Okay. So now it's going up every single frame, and then we're going to update the text of this label. Because this is a label and this script is within the label, we don't need to do label.text. We can just do text and it knows, okay? And then we're going to use we're going to say, and we're going to cast our time to an integer because it's not right now. It's delta's double, so this is going to be turned to a double, and time's double. So we're going to cast this to an integer, and then we're going to use dot to string to turn it into a string and display it in our and what you call it, and display it in and display it in our text, right, for the time. So there you go. And then one more thing, remember, cannot forget this. Cannot forget this. Exit tree. And what are we doing? We are doing event bus dot restart game disconnect. Oh, actually no. So sorry, I didn't realize that. I forgot we did that. So when we do lambda functions, guys, you guys don't need to disconnect lambda functions, okay? Lambda functions, they disconnect themselves, so we do not need to disconnect lambda functions. You only need to disconnect if it calls another function, okay? So in this case, no disconnecting needed. So that's it. That's our label. We can leave, and now we can actually go back and work on our game script. So in our game script, let's finish this off here. Almost done. We're almost done. We got 10 minutes. We can do this shit in 10 minutes. That's 10 minutes. Let's go, team. This is not too bad. The script is not too bad. It's not that long. We have a couple things. So one, we have the vector2d spawn. This vector2 holds a coordinate to where we're gonna spawn our ball. Remember at the start when I said that we're gonna spawn this in the middle, so it's perfectly in the middle. That's what that is for. So, and then we're gonna have our event bus once again, event bus, and then we're gonna have our private character body 2D, and that's our reference to our ball. So, we're gonna have an override method void to call the ready, right? As we have been having. In the ready function, we're gonna initialize our event bus, get node, event bus, root, event bus. There it is. There we go. And then now we're gonna do event bus dot restart game, plus or minus. We're gonna make a method called restarting game pretty soon. Restarting game. So okay, and then ball, and now we're gonna get our ball node, okay, which is the character body 2D, and then the path is just ball. The reason it's just ball, guys, is because remember this is in our root, so it knows all of the nodes done directly under it. So it knows that if I just say ball, that I'm talking about ball. Okay, so this is where we're actually gonna use our restarting game. Whenever these things like where's the player go, emit the signal AI scored, okay, remember it's gonna go here to our UI, and then it's going to update the UI. Once he updates the UI, it's gonna emit signal restart the game. Once he emits signal restart game, it's gonna go to our game, it's gonna connect it to restarting game, and then it's gonna restart the game, which we're gonna make the function later. So I think you guys, hopefully you guys can see why we're having an event bus in our game and why it's gonna be very useful for everyone around the project as you guys are working on your own things, you know. As people make events and whatnot, you guys are basically gonna be able to use it. For example, if I'm working on like a player controller and someone already made a event where like it says dead, then I can just reuse that event because it's already made, right? And since it's like universal, you know, so there's a lot of different uses. That specific example I just said maybe might not be valid for our project. We gotta see how we make it, but you know that it goes as we go. So what we did here is we got the ball node. Our spawn. When I said that we wanted to spawn in the middle, this is what we're doing here. We get the viewport. The viewport is this entire scene that we can see. The visible rectangle is what's in the screen itself, so inside the rectangle, and then we get this size, so you know the entire size, we divide it by 2. The size divided by 2, okay, the size of vector 2 because it's a coordinate, remember, it's like this and like this. If we divide it by 2, we're gonna get the exact middle. The exact middle is where we're going to spawn our ball. So, and then we can do ball.position equals spawn. So when the game starts, the ball is you're gonna see it's gonna magically go to the middle. And then once that sits there, we're gonna start, and then that's it. That's basically it. Now we're just gonna make sure we gotta do a restarting game function, right? A restarting game. So we can actually connect that. So it's this function right here. So whenever all those signals go through, and then restart game gets called, restart game is gonna. All we're basically doing in here in the restart game is we're setting the ball position back to spawn. So ball is gonna go out here and it's gonna be somewhere here. All we're doing is we're taking that ball, boom, get over here, and we're putting it back here in the middle, and we're starting the game. That's it. And then last function, very important. Remember, guys, I will say decline your PRs if you forget this step, guys. Please remember. You guys got it. It's just we need to exit the tree. So event bus dot restart game minus equals restarting disconnecting that signal. Oh, spell what the fuck? Exit. Restart. Okay, and that should be it, guys. I mean, now what we do is we test the game. We can press here and oh, what the fuck? Oh yeah, that's true. I don't have a so in this project I didn't really fully set it up. I just like set up a GoDot. So I don't have the launch and test that we have in our project. So you guys should be able to run here. Actually, no, you guys because you guys haven't set up this yet too. But if you're following this thing on a different file, you're not have set up. But it's okay. You can just run it over here in your actual GoDot. So build it real quick and let's see if it works. Okay, there's a timer. There's our AI tracking the ball. We're clamped to the scene. We're playing. The ball seems to be speeding up every 5 seconds. Oh, yeah, it's definitely speeding up every 5 seconds. Okay, the detections are good. Oh, okay. It scored, but our thing is still running, and the ball didn't restart. Why could that be? Let's find out. There's an issue here. What does it say? GoDot call, read-only span, can't emit non-existing signal. Restart game. Of course it can't emit that signal. Guys, restart game is not a signal we made. We made restart game, speedball, right? AI scored, and player scored. So that means that somewhere here, we actually misspelled restart game. So let's see, let's remember where could we call it here? Restart game. Okay, it's not here. So, but you know, you try to call it when you reach the player area 2D. That means it's in the player go, right? Emit signal AI scored. Okay, that's fine. So we emitted the signal. So then we went to our UI. Okay, we connected the signal, and whenever it scored, here it is. Emit signal restart game. This is obviously not our signal. So we have to make sure we type the right name. Restart. Now let's try that again. Now that we fixed our program and we debugged. It's building, not doing its thing, it's loading. I think. Oh, okay, there you go. Okay, our game's running. Everything seems to work fine. Let's see. Okay, the ball went back to the middle. The timer restarted. The AI got a point, and that's it. And the ball is speeding up every 5 seconds. That's it, guys. You guys made Pong, and now you can successfully get shit on by an AI that you can never beat. At least I can't. I mean, I try. I scored some points, but I don't know. I can't like ever definitely win. The only way to beat it is like if you get it when the ball's faster, but that means you also gotta like, so you gotta read that speed up. Oh, 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 yeah, yeah, he got me. Okay, but yeah, guys, that's it. Thank you. Hopefully you guys learned. If you guys have any questions, let me know. And that's it, guys. If you guys wanna learn how to, if you guys wanna know how to build the actual project, on your own, so you can just like literally have you on your desktop, you just play whenever. Let me know. I'll just reach out and I'll show you real quick. It's like 3 seconds. But yeah, thanks guys for those that watched the whole video. I hope this helped you guys, and I hope that this makes you guys a bit more confident on working on the project. Everybody that was accepted, they got accepted because we know that you guys can do it. Okay, so don't feel scared. Please ask questions. And yeah, bye bye guys.